I bought this solar stick lamp for about $1. I had to browse a bit because many of them had damaged solar cells. I don't know if they were actually damaged, but it seemed they had a crack somewhere on the inside or were dirty under the glass. So I saw maybe 6 out of 10 were almost perfect, like this. This is pretty good. Nice clean solar cell. So $1. For $1, allegedly it has a nice LED here inside. A 1.2 volt small, really small battery, and it charges the battery. Then when it gets dark, it turns on the LED light. That's how this works. So my idea was, depending on what I find inside, is that I could wire up maybe 4 of these and charge up a power bank only with solar energy. So I have to measure how much can this solar panel output. In the worst case scenario, I'll just replace the small battery with one of these 2000 rechargeable. This could run year round if I put it inside, and the battery charges very little in winter time. This could cover all that. This is so powerful. It's at least 20 times bigger from what I've seen on the internet. We have to see how big the battery it is inside. Maybe 10 times bigger. This should cover it year round. So maybe put it inside here into the tube or something. We'll see. So I'll have to take it apart and measure how much the solar cell can output. That's my main interest. So here's the small LED. It's kind of bright. Let me see if I turn it on. Yes. Wait. Yes. You can see it's quite bright. Yes, let's turn it off. And let's take it apart. 3 screws here. And we'll see what we got for $1. Actually, for less than $1. Maybe 80 cents. 80 cents, yeah. That sounds about right. So let's see. Oh boy. So the solar panel is hot glued probably to the top plastic. This is one piece and it's glued in. Only the 2 wires come out. And here's the small battery. Let's focus on it. So it's 1.2 volts and 40 milliamps. Okay, so 40, this one is 2000. That's at least 50 times bigger, according to my calculations. Yeah, so this is all it has. A charging IC transistor. No, it's an IC. It has 4 legs. This does all the switching and the charging and the discharging. Interesting. It has nothing else. Just a resistor, this chip thing, and the battery and the switch. All for $1, under $1, with a solar cell. Okay, so what I want to do now is measure the incoming voltage, not voltage, amperage from the solar cell. But the voltage is useful also. So let's see the voltage too. let's take out the multimeter. Is it DC? It must be DC. Let's see. So it must be in the light somehow. And then I measure the 2 poles, like there and there. Maybe turn on the multimeter, that would be helpful. Like that. And let's see. 0.04. What? Maybe if I turn it into the light. Oh boy. Now it's 0.89. Let me turn on a light. Like that. And now let's measure. Oh boy. I'll go closer to the light. Let me see. Whoop. Like that. Oh yes, it goes up to 1.4, just enough to charge the battery. This is nice. Okay, so that's about the voltage. That means I could wire up 4 of these in series. 4. Yes, that would be about 5 volts. Then charge the power bank directly with 5 volts. Or I could wire up about 10 of these in series. And then with 15 volts, use a car charger, a car cell phone charger. That will convert it down and stabilize it at 5 volts, and that will charge the power bank. So depending on the current, amperage, whatever you call it, how much power can it output at 1.5 volts. So how do we measure that? I think I have to cut one of the wires and replace it with the amp meter. So I just take this wire out brutally by hand. No soldering needed. Oh wait, this comes out even better. Okay. Yes, so I have to put the red wire to milliamps. It won't give much more than a few milliamps probably. So milliamps, and set it to where the fuck? Voltage. Amperage. Okay. DC 200 milliamps. M is milli. Micro, milli. I don't know. So let's see. What does it say? How can we measure? Okay, it's on. Maybe I have to turn this on too. Not like that. Oh, it doesn't see. Okay. I interrupted the circuit so the LED stays on. Okay. Let's see then. How can I measure this? Amateur hour, but I think I can reach it, and you can see the screen. So I put one here and the other one there, and it doesn't show a figure. How much is it? How much does it? Let's see. Is it even micro, milli? That's maybe too much. Another setting. Wire. Now how much is that? $40 milliamps. When it's on 20, the setting is on 20. I have to look it up. This is stupid. I don't know how much that is. So if it were 40, then the battery would charge in about an hour. I think it's just 4. That makes the most sense. And then in 10 hours, maybe 10 hours of sunshine, the battery can get fully charged. Yeah, because this is 40 milliamp hours. Yeah, that makes the most sense. So around 4 in the best conditions, maybe 10 come out of this. So if it's 10 milliamp hours, 10 milliamps, and I connect maybe 10 of them in series, that will trickle down through the car charger and blah blah blah. That will be equal to about 100 or slightly less than 100 milliamps at 5 volts. Not at 5 volts, hey. Not at 5. Oh boy. Not 5. I have it wrong. Okay. So if I put 10 of these in series, then the voltage will add up, but the amperage will stay the same. So it will be 15 volts and 10 milliamps, and transform to 5 volts, roughly 3 times the amperage. Then it will be 30 milliamps. I'd need 100 of these then to charge up a power bank, which requires focus. It requires 5 volts and 500 milliamps to charge up in like 5 hours, 6 hours. 6 hours, yes. So I need at least 100 of these solar cells. That's a lot. There must be something wrong with the efficiency. Let me measure it with better light, because this should be higher. It should be a lot higher. So let's see. The ankle bone connected to the jawbone connected to the ear bone, 2. What? No, I don't have a powerful enough source, light source. Maybe a flashlight. This is also too. The battery is empty. Perfect. So I'll play around with it some more and let you know in another video maybe.